Okay, so today we are going to start looking at logarithms. So when we talk about inverse operations, we talk about operations that undo each other. So for example, addition and subtraction are inverse operations. Multiplication and division, inverse operations. So when we have an exponent that's an unknown value, in order to solve for that, we have to do the inverse operation, which is a logarithmic function. So we're going to learn about logs today so that we can solve exponential functions when the unknown is in that exponent. So the common logarithm of a positive number x, denoted as log of x, is defined by the log of x equals k if and only if x equals 10 to the k. So k is going to be a real number, and we call this our common logarithmic function. So this is the most basic logarithmic function we're going to look at, and it's called the common logarithmic function. And if you look at your calculator, you'll see that you have a log key on your calculator. And if you don't, then you need to get a calculator that does have a log key, because there's no way to calculate logs without a calculator or a table. And we're not going to use tables in this course. We're going to use our calculators. So another important piece of information is logs have bases. Just like this is the exponent base, 10 raised to the k power, 10 is the base, k is the power. Logarithms also have a base. And if there's not a number written there, like notice this does not have a number written there, then we call it log base 10 of x. If there's not a number there, then we assume it's a 10. And that's the common logarithmic function when the base is 10.
Okay, so this is the easiest way to memorize this particular definition, is if we have log base 10 of x equals k. This is a base 10. So that's going to be the base of my exponent. And then I'm just going to switch my k and my x. So this is 10 to the k equals x. There are a million ways to memorize this definition, and they're all over the internet. There are songs, there's visuals, there's all sorts of different things that people have come up with in order to memorize this definition. I just think that this is the easiest. But if you don't like this way, you certainly don't have to use it, okay? The base of the log is the same as the base of the exponent. And then I just switch, I do a little x with my k and my x. So the k becomes the exponent, and the x becomes the answer. If we put in x as 10 to the negative 1, the y that we're going to get out is the exponent, negative 1. So the log of 10 to the negative 1 is negative 1. The log of 10 to the 0 is 0. The log of 10 to 0.5 is 0.5. The log of 10 to the 1 is 1. And we're going to talk more about these specific calculations in just a minute. I just wanted to give you a general overview of what this looks like. So it's always helpful to look at the graph. So the domain is going to have to be positive. So we cannot take the log of a negative number. So this is just like our square root function, right? We can't take the square root of a negative number. You can't take the log of a negative number either. So our domain is going to be from 0 to infinity. Our range could be any real number, so it's from negative infinity to infinity. We do have a vertical asymptote at the y-axis. Our graph is continuous. I can draw it without picking my pencil up, and it's increasing. And it passes the horizontal line test, which means that it's 1-to-1, which means that it also has an inverse. And this is the inverse. So we're actually looking at logarithms and exponentials as inverse functions. So we'll kind of sum everything up with that at the end of class today. So before we go any further, let's look at some concrete examples of what this common log is. So if I'm trying to evaluate the log of 10, that's basically saying 10 to what power gives you 10? Well, 10 to the first power gives you 10, right? 10 to the 1 is equal to 10. That's why the log of 10 equals 1. So let's look at the next one, log of 100. So 10 to what power gives you 100? 10 to the 2 gives you 100. So that means that the log of 100 is 2. So C, log of 1,000. So 10 to what power gives you 1,000? So log of 1,000 is 3. Ooh, what about log of 1 over 10? So we have to think about exponent rules. What puts something in the denominator? What kind of exponent? Do y'all remember? Good, a negative, exactly. So just to recall, the exponent rule, 1 over x is the same thing as x to the negative 1. So if we're looking at 1/10, we want to know 10 to what power gives you 1/10? Negative 1, right? So that's why log of 1 over 10 equals negative 1. So when we think about E, the log of 1 over 100 means 10 to what power gives you 1 over 100? So 10 squared is 100, but to make it go into that denominator, we have to make the exponent negative. So log of 1 over 100 equals negative 2. What about log of 1? 10 to what power gives you 1? So anything raised to the 0 power just gives 1. So the log of 1 is going to be 0. We don't even have to do these calculations ever by hand. We're going to use our calculator. But I did want you to do a few by hand because I wanted you to understand the concept. And I think that to understand the concept, you really kind of have to go through the process on a few. Okay, so now let's use our calculators to evaluate each logarithm. So go ahead and find the log key on your calculator and just type in log of 10,000. What do you get for log of 10,000? 4. What about the log of the square root of 0.001? Is everybody practicing this with your calculator? So that would be negative 3/2 or negative 1.5. Now notice for C, this is 5 times log of 0.01. So the log of 0.01, this is representing one single number. So this is 5 times whatever this number is. So that means that we have to do the log first and then multiply by 5. So your calculator should know those order of operations, but let's double check. So we're going to say 5 times the log of 0.01. The answer is negative 10. We talked about the common logarithm, but really the logarithm can have any base a. So a logarithm with a base a of a positive number x, denoted log base a of x, is defined by log base a of x equals k if and only if x equals a to the k. So a is greater than 0, can't be 1, and k is a real number. This is the log function with base a. So a couple of notes. The common logarithm is log base 10, but we just write log of x. But it is log base 10 of x. We just write it log of x. The natural logarithm has a base e. So it's log base e of x. But this comes up so much, it has its special notation. So we write it ln of x. This is the natural log of x. So these are just a couple of notation notes. If you don't have an a there at all, then it's a 10. If you see ln, then it's going to be log base e. So let's evaluate some logarithms with a different base. Let's do these without our calculator because I want you to think about what this means. So log base 2 of 8. That means 2 to what power gives you 8? 2 to the third power. Good. So that means that log base 2 of 8 equals 3 because 8 equals 2 to the third. Notice this is exactly what this definition tells us, right? Okay, now let's think about this one. Log base 5 of 1 over 25. So that's 5 to what power gives me 1 over 25? Negative 2, because 1 over 25 equals 5 to the negative 2. Now, I put two little notes here. Notice that log base 2 of 2 cubed, which is just 8, right, is equal to 3. All I did was replace this 8 with that 2 cubed. Do y'all see that? Same thing here. Log base 5 of 5 to the negative 2 equals negative 2. So my log base is 5 and my exponent base is 5. If those bases are the same, the exponent is my answer. So the reason why I wanted you to see these two examples written in this way is because now we're going to learn a couple of properties of logarithms. So the following inverse properties hold for logarithms with base a and any all real numbers x. So I have log base a of a to the x is equal to x. So I have the base of my log and the base of my exponent. These have to be the same number. If these are the same number, then the exponent is equal to the answer. So if I have a, the base of my exponent, is raised to the power of the log base a of x. If the base of my exponent and the base of my log are the same, whatever I'm taking the log of is my answer. So notice we have a couple of things to memorize for this section. So we have our definition that we just learned. So going back a little bit, you want to make sure that you know this definition. You'll want to know that the common logarithm is just log of x. You want to know that the natural log with base e is just written as ln x. And you'll also want to know these two properties. Okay, so let's simplify the expressions. So notice the key to these properties is the base of the log and the base of the exponent have to be the same, right? So let's look at example 4, simplify the expression. A, log base 6 of 6 to the negative 1.3. So do you see that the base of the log is 6 and the base of the exponent is 6? So what is my answer going to be here? The answer is going to be negative 1.3. Okay, so now let's look at B. So this is the exponent. 5 is my base. It's raised to the log base 5 of x plus 8. So notice the base of the exponent and the base of the log are the same. So what do you think the answer is going to be here? X plus 8. Okay, so let's look at part C, log base 2 of 1/8. Can I rewrite this 1/8 as 2 to some power? Well, I know that what? 2 cubed is 8. How do I make that 8 go into the denominator? I just make the exponent negative, right? Yeah, so that would be negative 3. Because you could rewrite log base 2 of 1/8 as log base 2 of 2 to the negative 3. So the natural log of e squared. What is the natural log again? What is this ln? So remember, log base e of x is going to be the same as that ln of x. This is really log base e of e to the second power. So it would be 2. So some people find it a whole lot easier if they write it out like this to see it. So you might want to rewrite your ln's as log base e if you're struggling a bit with that.